So as far as similarity is concerned, like when two objects that you take, let's say, for example, if I take two triangles now, or let's say two rectangles. Now what happened is, this is the first rectangle, this is the second rectangle. Now, when you notice that the aspects, or like you can say the lengths or height or width that you talk about, if they're in the same ratio, okay. So now, for example, this angle. Now, for example, this is right angle. The corresponding angle should also be right angle. If I have got, let's say, this angle as 90 degrees, this also has to be 90 degrees. Now, in order to be similar, what happened is that the ratio of the lengths has to be the same. So just to begin up with an example of triangle, first I'll take, let's say triangle, I'm taking triangle ABC and triangle PQR. So if two triangles are similar, now what happened is that if triangle ABC is similar, we show similar with this squiggle sign with triangle PQR. Now, what does this mean is very interesting fact here. That is, the first one is the angle A. Look at the corresponding angle A must be the same. So angle A must be same as angle P. Angle B must be same as angle Q. That is this angle, and angle C automatically becomes same as angle R. So that's something that is really comes out of the similarity concept. So now what happened is that in order to prove the similarity of the two objects, you got to prove this particular thing. So if now, for example, if they, let's say this is a triangle here. Now that's this one triangle created. This is the triangle one, and to this triangle two. And I wanted to prove that these two triangles are similar. Now, when you prove these two triangles are similar, what you got to prove is the corresponding angles are the same. So now, for example, here is a right angle, and you notice that the other angle that is you have got here is also right angle. So that, okay, so this is, take, let's say T, A, B, P, and Q. So let's say angle T that you see is same as angle P because the right angle is 90 degrees. Now, the second angle that you notice here is they're vertically opposite. That is, this angle, angle ABT, is equals to angle QBP. So that here these two angles are the same. Hence, because these are vertically opposite angles, so vertically opposite angles. Now, automatically, since you prove that these two angles are the same, what happened is the third angle corresponding is automatically the same. So in this case, angle A has to be same as angle Q. So as a result of this, now we can prove that the two triangles, triangle B and triangle A is same as, so T is same as P. So, okay, so P and B same as B itself, so B. And then finally the angle A, which is angle A corresponds to angle Q. So that's angle Q. So you can't just write down in any random order. So they are similar. So when you say similar, it means that they are like with this squiggle sign. So now when you prove that these two triangles are similar, there's the interesting fact that comes out is that their side ratios has to be the same, the corresponding side ratio. What does it mean is, if I take the side length TB, it will be same as PB. It will be also same as BA. Ratio of the sides has to be always same. BA over BQ and equals to TA over PQ. So what does it mean is that if I take, let's say this is 10, this is maybe 5, and if this length has been given as 8, how do I find out this value of x? So what happened is that if you take the ratio and that I've taken here, you can simply find out the missing value x using this particular ratio. So now you can just plug in the value. So so TA is nothing but 10 over PQ, which is 5, equals to BA, that is 8, and over BQ, that's x. So you could just cross multiply. So 10 times x equals to 8 times 5. So that gives me 40 over 10. That gives me the answer as 4. So you can see that this ratio is 2:1 because this is 10 and this is 5. So it's exactly half of this. So this is 8. This has to be 4 because half of that value. Okay, so since here what we have got is the angle D that you see is common. So I'm going to take this triangle ECD, like and probably the bigger triangle. So you can see that angle D is common. So angle D is common angle. Angle E that you see here is same as angle B. So angle E equals to angle B, they have already given. And automatically the angle C equals to angle A. So angle C equals to angle A. That's the third angle automatically left. So when you take the two triangles, the triangle DEC, DEC, so DEC similar to triangle. So triangle DEC is similar to triangle DBA. So triangle DEC is similar to triangle DB. So it's an important thing that you follow a particular order. Now what you do is, because two objects are same, so their aspects has to be in the same ratio. So DE over DB equals to EC over BA equals to DC over DA. Now, which are the measurements are given to us? Let's substitute that. So first we have been given DE, that's x plus 2, or BD, that I can see B to D has not been given to us. B to D has been given to us 20. Here it is clearly given 20. So BD is 20 equals to EC is x, so EC is x upon BA is 12. And if I solve this, so 12x plus 24 equals to 20x. And from here, if you solve, this will be 8x equals to 24. So that gives me x as 3. So if you take x as 3, these two objects are similar.
So for the E part, what we have to set up is the two triangles. Obviously, you can see A, B, E, and D, B, C, but you have to set up the equality. So angle B that you can see is common in both. So angle B equals to angle B, that's common angle. So you're going to take that as one thing. Now angle E has been given as same as angle C. So angle E equals to angle C, and then eventually the angle A automatically becomes angle A equals to angle D. Here, angle B is vertically opposite angle. You can see vertically opposite angles are the same measurements. That's like I have taken angle B equals to B. So now when you set up the two triangles that are similar, the two triangles that are similar here is B, E, A. So B, E, A is similar to triangle B, C, D. B, C, D, same order. Now, blindly can write down the ratios. BE over EA equals to, so BE over BC, so corresponding ratios. So BE over BC equals to EA over CD equals to BA over BC. BD. You don't need to even look at the diagram. So BE is now has been given to us. BE has been given to us as 3 over BC has been given to us as 5 equals to EA. EA has been given to us as 4 over DC or CD is the same thing, has been given to us as X. We don't need this. So what we do is we can solve for X by, so it'll be 3X equals to 20. So that gives me X as 20 over 3. That's the exact value for X. So for the next part, which we have got here, is to calculate the X value. Here what we have is, like, we take two triangles. Let's say I take this big triangle, which is X, U, and V. The triangle X, U, and V, and triangle X, Y, and Z. So X, Y, and Z. So as you can see, the X is a common angle. So first write down X, angle X equals to angle X. That's a common angle, you can see. That's a common angle. Now, this Y angle is equals to angle U because corresponding angles. It forms like letter F. This corresponding angle. So angle Y equals to angle U. That's your corresponding angles. And similarly, angle Z equals to angle V. That's the corresponding angle. So angle Z equals to angle V. So now the proper order is triangle XYZ is similar to triangle X, U, and V. Triangle XYZ similar to triangle XU and V. So now you just don't even need to look at this. Just write down the ratio as XY over XU equals to YZ over UV equals to XZ over XV. So XY, XU, YZ, UV. and xg, xv. So now after this, you just put in the values. So xy length, what's xy length? So xy length is 5. So 5 over what's xv length? So um, xy length is 5 here. So this part is 5 and upon x u, this is actually xu because this angle is xu. So xu length is 7. So total is 7 equals to yz length, yz that you talk about, yz over uv. So yz is same as, since here they have given it as equals, there's 5. So yz is 5. So this is 5 because isosceles triangle, you can see these two marks. So 5 over uv, which is x. And from here, what you get is 5x equals to 7 times 5. And so that gives me x as 7. So that's how you do this particular question.
on. So here what we see is that this angle R and angle T, they are the same. And this angle is vertically opposite. And automatically this angle has to be same as angle P. So we get R, triangle R, and then here will be T, Q, here will be Q because common angle, and angle S, that is S, so here it is P. So triangle RQS is similar to triangle TQ and P. So what you do is RQ over TQ equals to QS over QP equals to RS over TP. So whichever the values are given. So RQ is not given, TQ is not given, RQ is not given to us, TQ is not given both. So QS has been given to us as 8 and PQ has been given as X, RS is given us as 10 and TP has been given us as 9. So X will be 9 times 8 over 10, that's 7.2. So that's the exact value of X for the first. Now for this question, basically AC is this bridge length. AC is what you have to get is bridge length. And they're saying that this should extend like 40 meters both the side of the river. So that we'll do later on. But first what we do is get this length AC. So 400, you can see the triangle ABC is similar to triangle EDNC. So 400 over 30 equals to AC over 70. That's clear indicator. So AC you get as 400 times 70 over 30, and that comes to let's say, so this comes to be 933.3, and since it has to extend basically both the sides as 40 and 40, so the exact length of the bridge will be plus 80, so that comes to be 913.3 as the final answer. This is actually 1013.3. So now, as long as the area, I mean, if the two objects are similar, so for example, if let's say I'm taking a, let's say triangle, um, let's say this is ABC, A, B, and C, this 8, 4, and if I take another triangle, basically here it is, let's say 4, 2, so like P, Q, and R, these two triangles are similar. So what does it mean is that you can see the ratios, the side lengths are in same ratios. This is 4, this is 2. So the ratio is 2 is to 1, and same is with 8 is to 4. So these are similar triangles. Now what happened is that if you look at the area of the first triangle, if I find the area of the first triangle, which is half times 8 times 4, that comes to be 16. And area of second triangle is half times 4 times 2, that comes to be basically 4. And if I divide A1 over A2, that comes to 16 over 4, that comes to be 4. Now, what happened is that if you notice here, what's happening is the area, if I look at the ratio of the sides was 2, and area is 2 squared. So area ratio is actually 2 squared. So whichever like objects, whenever you take the objects, let's say there is something defined as scale factor. Scale factor is nothing but the aspect ratio. Aspect ratio means the basically the side lengths in ratio, or particular like any other dimensions for a 3-dimension object also. So in this case, what happened is that if you have A1 over A2 for any area, A1 upon A2 equals to
scale factor square. Now, scale factor is nothing but the multiplier or the ratio of the sides or ratio of the dimensions. So that's the area varies the square of the scale. And it is also, if for example, let's say if it is side one and side two, so it'll be side one squared over side two squared. If it is height related question, it will be height one squared over height two squared. So it's the same thing. So as long as the similarity is concerned, when you find out the area, just remember that it'll be in square of the scale, or you can say square of the side ratios or square of the height ratios. Similarly, if it is three-dimensional object, let's say if you got, let's say, a volume, let's say, for example, cylinder here, which is similar to the other cylinder. Now you can see here. So let's say if this is 2 and this is, let's say, 8, and if this is 1, so this is, let's say, 3, uh so this is 1, and then this is 8 over 3. Actually, it'll be 8 over 3, 8 over 2, which is like, uh 1 second. So since this ratio is 2:1, this height ratio is going to be 8:4. So this will be also there. Now what you see interesting part will be here also. Let's say if you want to find out the surface area ratio. So surface area ratio will be SA1. If, for example, I want to find a chord surface area, SA1 or SB, let's say, will be simply a square of the scale. Now scale you can see is 2:1. 8 upon 4 is 2. So it will be simply 2 squared, which is 4. So that's what I mean by scale. Now let's take a proper problem on this thing. But just before I go ahead, even volume, like when you talk about volume of the object will be V1 over V2 will be scale cube. So scale cube. That's the volume ratio. So the surface area varies as square and volume varies as a cube of the scale. So here what has been given is that there are two similar cylinders, and their surface areas are given as one is 1600, other is 900. So the surface area ratio will be, so SA1 or SB equals to, which is 1600 over 900, that's already given. This will be equals to the square of the dimension, like square of the scale. So scale is 5 over x, you can say. So 5 over x squared you could do, or you could do 5 squared over x squared. So that is going to be 1600 over 900. That's going to be 5 over x the whole squared. It simplifies to 16 over 9. So if you root this, you get 4 over 3 equals to 5 over x. And that gives you 5x equals to 15. 4x equals to 15. And that gives you x is 15 over 4. Now, as far as the volume of the similar objects is concerned, what happens is that the volume V1 upon V2 will be in the ratio of the cube of the dimension. So like it'll be 2 cube over 4 cube, or you could have just done like 2 over 4, that you get a scale and then cube that. So 2 cube over 4 cubes, so 8 over 64, which is 1 over 8. So since we have got already the B of the small one, so we got like 10 over V2 equals to 1 over 8. So that gives me V2 is basically 80. So volume always varies as cube and area varies as square of the dimension. Just remember that. So in this problem, when you notice, basically it has been given that the surface area is actually given, and they're asking the volume ratio. So this is a little tricky question. So first, what you do is, since surface area has been given, so let's say I take S1 as the surface area of this and S2 as surface area of this. I mean the cross section area. So S1 over S2 will be equals to K squared, which is scale squared. So since it is 9 over 25 equals to K squared, so K will be 3 over 5. Now what I say scale means, if I take the radius of this is 3, the radius of this will be 5. If I take the height of this is, let's say, 7, height of this will be like, I mean, in a ratio of 3:5, basically. So whatever it is given, now just remember the scale what we have got here. So the scale that we got is 3 over 5. So now V1 over V2 will be scale cube. So scale cube, which is nothing but 3 over 5 the whole cube. That's nothing but 9, which is 27 over 125. So that will be the volume ratio. Now for this problem, what we have is we have to have V1 upon V2 basically equals to the scale cube. So scale is 10 over 16. the whole cube. So V1 is 875 over 2240 and equals to basically this is um, 5 over 8 the whole cube. So if these two are the same things, then they are equal. I mean, they are similar, but actually this value and this value here, they're coming different. Hence, these objects are not similar. Okay, so this is one of the past exam questions. So what we have is there are two similar glasses. Um, the height of the big glass is 12, and you have to find out the height of the small glass. So you have to find out basically this height out here. So since you can see that the ratios or the dimensions has to be the same, it's an object similarity. So it'll be 12 over h equals to 8 over 6. And when you solve for h, so it'll become 12h equals to basically this is 4 over 3. So it'll become h equals to 12 times 3 over 4. That's 9. So this is 9 centimeter. So this height is 9 centimeter. Now, the volume of the large one is 550. So volume of this one is 550. I mean, this one is 550. You have to find the volume of the small one. So let's say I take this as V. Now, 550 over V equals to the scale cube. Now, scale here is 8 over 6, the whole cube, which is, you can say, basically 4 over 3, the whole cube, which is 64 over 27. So 550 times 27 over 64, that's the volume of this small can.